Although crocodilians are without a doubt some of the deadliest carnivores alive today, they also occasionally consume fruit. The pond apple is even sometimes called the alligator apple due to the preference alligators have for it. Of course, fruit doesn't make up a large enough portion of the diets of modern crocodilians for them to be classified as omnivores, but their prehistoric relative Iharkutosuchus was a true, specialized herbivore. Indeed, it was able to process its food more efficiently than any modern herbivorous reptile. Iharkutosuchus was not the only extinct relative of crocodilians who became a plant eater. Herbivory and omnivory evolved multiple times within the larger clade Crocodilia belongs to, Crocodilomorpha. However, most of the others were terrestrial species only distantly related to true crocodilians. What sets Iharkutosuchus apart from them is that it was part of the branch of Crocodilomorpha which ancestrally already looked and acted like the crocodilians alive today, Neosuchia. Even though it did not belong to Crocodilia proper, Iharkutosuchus was a herbivorous crocodilian in all but name. Iharkutosuchus belonged to the Neosuchian clade Hylaeochampsidae. Like it, the other Hylaeochampsids were small and had short, round snouts. The Hylaeochampsid Acynodon is also thought to have been a herbivore, although its teeth were not as complex as those of Iharkutosuchus. Iharkutosuchus's fossils are found in the Hungarian Csehbánya Formation, which is part of the greater Iharkut locality. It lived 85 million years ago during the Santonian age of the Late Cretaceous. Late Cretaceous Europe was less of a continent and more of a collection of islands connected by a shallow sea, and due to the limited habitat available, many of the local dinosaurs were smaller than their mainland counterparts. All definitive Iharkutosuchus fossils are skulls. Other Neosuchian fossils have been found in the Csehbánya Formation, some of which probably belong to Iharkutosuchus, but since they are disarticulated, their identity cannot be confirmed. Still, even without postcranial remains, analysis of the skull's oxygen isotope composition has been able to confirm Iharkutosuchus spent most of its time in swamps, ponds, and lakes. It therefore seems that, despite how much it had changed from crocodilians, Iharkutosuchus retained its ancestors' semi-aquatic lifestyle. The largest Iharkutosuchus skull measures a mere 11 centimeters long, and its total body length is estimated to have been just 0.8 meters long, smaller than any modern species of crocodilian and half the length of a cynodon. Its diminutive size doesn't appear to have been due to island dwarfism. The other Hylaeochampsids were never very big, nor were the terrestrial plant-eating crocodilomorphs. Meanwhile, the size of the contemporary carnivorous Neosuchians was comparable to that of modern species. As a consequence of its herbivorous diet, Iharkutosuchus's jaw muscles were dramatically rearranged from those of its carnivorous ancestors, and as a result, it had fewer openings in its skull. Unlike crocodilians and most other reptiles, Iharkutosuchus's teeth were heterodont, meaning they came in multiple distinct shapes. The first 5 rows were spatulate, with large crowns. Like the incisors of mammals, they were used to bite off foliage. The 6 rows behind them deviated even more from those of crocodilians, with 3 cusps on their crowns. But it was the larger teeth at the back of the jaws which were truly special. They were wide, flat, multi-cupsid, and fit together precisely. A few terrestrial land crocs like Chimaerosuchus had similar molar-like teeth, but the only living animals with such complex teeth are mammalian herbivores. Something Iharkutosuchus shared with both groups was the ability to efficiently chew its food, something crocodilians and most other modern reptiles are incapable of. The tuatara of New Zealand is an exception, but even its food processing capabilities pale in comparison to Iharkutosuchus, whose teeth and jaws rivaled the sophistication of many mammals. Chewing was divided into 2 phases. First, the front teeth were used to crush the food into smaller pieces. The plant matter was then grinded by the back teeth with a side-to-side motion. This created extensive wear. Fortunately, unlike mammalian herbivores, which have a permanent set of adult teeth, Iharkutosuchus continuously replaced them, much as crocodilians do. Under normal circumstances, this tooth replacement would have threatened the precise occlusion which made Iharkutosuchus's teeth so efficient. However, the dental wear on the molar-like teeth is fairly uniform, so it is thought they were replaced simultaneously. Iharkutosuchus's rate of tooth replacement was also much faster than in other reptiles, so the replacements were almost fully grown by the time their worn predecessors finally fell out. All of this came together to ensure that its ability to efficiently chew its food remained uncompromised. Based on the microwear patterns found on its teeth, it appears that Iharkutosuchus consumed a wide variety of plants. The teeth belonging to a juvenile Iharkutosuchus bear the mark of consuming predominantly softer materials, while those of adults possess wear from both soft and hard food. Additionally, the environment preserved in the Csehbánya Formation had distinct wet and dry seasons, so Iharkutosuchus likely consumed different types of plants throughout the year. It has also been proposed that Iharkutosuchus may not have been a strict vegetarian, supplementing its plant-based diet with invertebrates, much like how crocodilians supplement their meat-heavy diets with fruit. Invertebrates form most of the diet of crocodilian hatchlings, but Iharkutosuchus's potential success in such ventures was far more limited, as the muscles responsible for rapidly closing its jaws were greatly reduced from those of its predatory ancestors. Although the fauna of the Csehbánya Formation remains obscure, a great deal of research has been done trying to understand Iharkutosuchus's home. Among the dangers Iharkutosuchus coexisted with was a larger Neosuchian similar to Allodaposuchus. Notably, its bite marks have been found on an Iharkutosuchus skull roof. This was likely the result of predation rather than mere scavenging, since predators rarely leave traces like this on the skull when feeding. However, the deadliest predator in the water was not a fellow crocodilomorph, but Paleoenvironment, a species of freshwater mosasaur. Other Neosuchian bones found in the Csehbánya Formation belong to a more terrestrial form similar to Theriosuchus. Crocodilomorphs such as these were long gone elsewhere in the world, but the islands of Europe served as a refugium for a number of lineages that had perished elsewhere. Since Iharkutosuchus and Acynodon are the only known Hylaeochampsids from the late Cretaceous, they themselves may have been an example of this phenomenon. That is not to say that Iharkutosuchus only lived alongside evolutionary relics. Another contemporary terrestrial crocodilomorph, the small Notosuchian Doratodon, might be the oldest known Cebecid. Although Doratodon itself wasn't very big, Cebecidae survived into the Cenozoic era and included the largest terrestrial carnivores after the demise of the non-avian dinosaurs. Another unusual neighbor of Iharkutosuchus was the pterosaur Bacchane Draco, who was one of the last of the Tapajarids. Besides serving as a haven for relict taxa, late Cretaceous Europe was also a crossroads between the otherwise distinct faunas of the two hemispheres, and Santonian Hungary was no exception. Among the northern Laurasian fauna native to the Csehbánya Formation was the small ceratopsian dinosaur Ajkaceratops. Additionally, fossils have also been found belonging to an abelisaurid, a large type of theropod otherwise restricted to the southern Gondwanan continents. A sauropod tooth has also been found at the site. Even if it belonged to a dwarf like the later Magyarosaurus, the sauropod it belonged to was still likely the largest herbivore which coexisted with Iharkutosuchus. Other contemporary dinosaurs such as the early diverging iguanodontian Mochlodon were relict taxa like Iharkutosuchus. Other examples are the armored notosaurid and ankylosaurs Struthiosaurus and Hungarosaurus, the latter of which is notable for its proportionally longer forelimbs. They were the last members of Struthosaurini, a notosaurid clade which, despite its obscurity, had been common during the early Cretaceous. Even though Iharkutosuchus lived alongside many so-called living fossils, it is also an example of why the term is misleading. It may have been one of the last Hylaeochampsids, but it became incredibly specialized compared to its ancestors. It also shows just how adaptable crocodilians and their relatives, who themselves are often called living fossils, were. While crocodilians are carnivores who indulge in occasional fruity snacks, Iharkutosuchus built upon the same template until it ended up surpassing all modern herbivorous reptiles.
Thank you for watching, and a thank you to the Mandalorian for narrating this video. If you enjoyed it, please remember to hit the like button, and subscribe if you'd like to see more. Finally, be sure to have a great day.